Discrete and continuous.
Sorry, discrete and continuous domains. I don't know. I got a little tickle in my throat there. So here's what we're doing. A blank domain is a set of input values that is only certain numbers in an interval. That is either discrete or continuous. What we're looking at here is single numbers within a domain, and it's not every number in between them. So it's consisting only of very singular and specific input values, and that's what we call discrete. A blank domain is a set of input values that consists of all numbers in an interval. So it's not just 1, 2, 3, 4, and 5 like the first one. It's instead considering all the numbers even in between 1 and 2, between 2 and 3, 3 and 4, and 4 and 5. This is not looking at discrete integers. This is looking at a continuous look of all numbers within an entire domain. So this is called continuous. When we think about these two things, discrete and continuous, we want to think about specific examples in life to try and grab onto these ideas and these definitions. Something that's discrete, or a domain that is discrete, could be something like a certain amount of sales, like CD sales. You can sell 1 CD, 2 CDs, 3 CDs, but you can never really sell 2.35 CDs because it's a physical thing, as opposed to something that's continuous, which could be, maybe the amount of cake you ate today, which could be 1 piece, it could be 1.5 pieces, it could be 1.25 pieces, it could be 3 pieces, and then you just dug your hand into the frosting because you really needed more. So there's a little bit more of a gray area there. That's more of a continuous set of data. So let's look at a couple examples. Example 1. I have a function y equals 16x that represents the cost y in dollars of x tickets for a museum. Graph the function using the domain 0, 1, 2, 3, and 4. Okay, so it's telling me that this function y equals 16x is going to be using a domain of 0, 1, 2, 3, and 4. So it gives me these input values and says, find the outputs, graph the function. Okay, so I'm going to take the 0, put it into the equation. 16 times 0, 0. Take the 1, put it in the equation. 16 times 1, 16. What about put the 2 in? 16 times 2, 32. 16 times 3, that's going to be 48. And 16 times 4 will be 64. Cool, now I have my entire domain and range that I've just found. Now I can plot the function. I can plot the point 0, 0, that's a nice easy one. And then along the bottom I'll say that this is 1, 2, 3, and 4 for my x and my inputs. And along the side, why don't I say that this is something like, I gotta go up pretty high, so let's say 5, 10, 15, 20, no, that won't be enough. These will be 10s, 10, 20, 30, 40, 50, 60. So this is 60, that's 10, 1, 2, 3, and 4. Very good. 0, 0 is done. I can do 1, 16, which is about right there. I can do 2 and 32, which is about right there. I can do 3 and 48, which will be almost at 50, but not quite. And 4, 64, a little bit off the charts. Now, the question is, when I go to graph this, should I put a line through? Should I consider all of these points that lie in between here, or all the points that lie in between here? Is it appropriate for me to now say, I'm going to put this line through the whole thing, and I'm going to say, all of these points exist? Well, I really have to think about the context of the problem. What am I talking about? My inputs are X tickets for a museum. I had 1 ticket, 2 tickets, 3 tickets, 4 tickets. Can I have 2.5 tickets? Can I have 1 3/4 tickets? No, I cannot. That line goes away. What we have here is a very discrete number of input values. I can't look at all the numbers in between. It's not continuous. So this is me graphing this function with singular integer values. Now let's take a look at this one. A cereal bar contains 130 calories. Okay. The number C of calories consumed is a function of the number of bars eaten. Graph the function. Is the domain discrete or continuous? Okay. Well, this actually should be a little bit easier to graph. Why don't I say this is inputs of 1, 2, 3, and let's do 4 again. We'll look at my thing. I wasn't given a function, but it should seem easy enough. If I eat 0 bars, I've eaten 0 calories. If I eat 1 bar, it tells me I've eaten 130 calories. 2 bars would have to be 260 calories, and 3 bars would have to be 390 calories. So when I come over here and I do, let's say this is 130, this is 260, and this one is 390. I can plot my points. 1, 2, 3, and 4. Cool. So now I have what looks like, again, a nice straight line, and I have to ask myself, is it appropriate for me to now put the line through here and say, I'm not just looking at if I eat 1 bar, 2 bars, or 3 bars. Can I think about if I were to eat 3 and 0.65 bars, or 1 and 5/7 bars? Is it possible to stop yourself in the middle of eating 1 to 2, 2 to 3, 3 to 4? Yes, it is. This is considered to be continuous data because you can look at all of the small little bits in between, and they are realistic, they are true. So that's continuous data. Now let's take a look at one more example, and it's just a multiple choice. What is true, A, B, C, or D? What can I say is a true statement about the table that's given here? I'm conducting an experiment on speed of sound waves in dry air at 86 degrees Fahrenheit. You record your data in a table. Okay, so I have input values of 2 seconds, 4 seconds, 6 seconds, 8 seconds, and 10 seconds. And at those input values of seconds, I have a specific distance, output distances. So what's true? That the domain is from 2 to 10 and it's discrete? That the domain is from 2 to 10 but it's continuous? Or maybe it's that the domain is from 0.434 to 2.17, so that's looking at this side now, and it's discrete. Or that the domain, again, is the same as this side, but it's continuous. So I guess there's 2 parts to this. Is the domain on this side? Is it the input? Or is it on this side? Is it the output? Well, I really hope that from the last one we were able to really grasp the concept that the domain is the input values, the x values. So that means that we shouldn't even be looking at C or D. We should know for a fact, because A and B are talking about the actual domain, that we just need to now discern, is it discrete or is it continuous? So now I need to ask myself about the situation. I'm talking about time. Is it possible for me to think about time that happens in between 2 and 4 seconds? For example, 3 seconds happens in there. Is it completely crazy for me to try and think about what the distance would have been at 3 seconds? No. So that must mean that this isn't completely discrete. It's not just about 2 seconds, or 4 seconds, or 6 seconds, or 8 seconds. It also includes all those times in between. So this must be continuous. B. Woo! Did it. All right. That's it for today. Again, make sure you write down the questions if you have them. I'd be more than happy to talk about them in class. Do the assigned problems. Don't ever forget that. And I will see you guys later. Remember, keep that smile on when you're mathing.